Okay, so this is a TRV, standard thing we see on radiators, hotly debated for especially heat pump installations because of that little valve in there. So if you can see that black rubber, that is currently open, which will allow water to flow into the radiator, but it is also probably 2 or 3 degrees in this room at the moment, so it would never be called to close at this temperature. So I'm going to come back in a moment after it's been sitting on a radiator to warm it up, and you can see just how much it closes. So right now this is sitting on top of a little radiator, and as that head senses the ambient air temperature, that little black sucker plunger will gradually close off that gap, which will reduce flow. So flow will come in here from your copper pipe and up and through this one into the radiator. Now the problem this causes with heat pumps is this will eventually entirely close, which will eliminate or remove the water content of the radiator from the rest of the system, and that means that the heat pump will no longer have this water available to it. So that reduces system volume, and heat pumps love system volume. So the effect that'll have is there'll be less water circulating through the heat pump, which means the reduced amount of water will heat up faster. The heat pump will then see its job as being done and turn off, and this ends up creating what's called short cycling, the heat pump switching on and off. And the more frequently a heat pump does that, the less efficiently it runs, because a heat pump, when it first starts up, has to power up the compressor, and that requires a fair amount of energy, and they are definitely not near their 300, 400, 500% efficiency when they first start up. So the less starts you can have per hour, the more efficient your heat pump will be. And anytime you've got TRVs on the system, you're reducing that system water volume, and it increases short cycling. So we try and avoid putting TRVs on where we can, and if we can't, through various reasons, we must add what's called a volumizer onto the system. So that essentially adds pseudo volume. It's not needed to actually heat the house, but it's needed to keep the heat pump running efficiently. I'm going to come back to this in a little while once it's closed up and show you how much it does close. So this has been about 10 minutes now with it on an oil radiator and covered up to try and get some heat trapped around that head, and you'll see it's gradually closing, much slower than I thought it would close, but I'll come back when it's fully closed. Okay, so this is now 30 minutes from when it was wide open and cold in a room that was a few degrees above zero. And now it's been sitting on an oil heater and covered up to try and simulate the temperature increasing in a room, and we can see that took half an hour. And now there is zero flow through this, so that radiator water volume is not available to the system. I'm going to turn off the heater and uncover the TRV now and see how long it takes to open back up and make that water available to flow through the heat pump or boiler. Okay, so this is now pretty much fully open again, and you can see that gap there has opened up, so water can now flow in here from your heating system into your radiator through this one, and that's taken about 20 minutes to get to that level, but that has been on a frosty ground outside. So if this was inside, it would open up considerably slower. So that's pretty much an hour to close fully and open fully. So you think that that radiator water volume is either entirely unavailable or partially unavailable to the heat pump. So TRVs, whilst they are, or they were, a great little invention for higher temperature systems with non-condensing boilers, for the newer generation of more modern lower temperature heating systems where we want to increase efficiency and reduce short cycling of our heat sources as much as possible, they do cause more problems than they solve nowadays. Well, I hope that's given you a little insight into how TRVs function and why we try and avoid them, and I will get some more videos together shortly.